Hello, this is Mr. Win, and this video is over solving rationals with applications. So solving rational equations is very similar to adding and subtracting, but with one final step, and that's solving. You already know how to combine multiple fractions into a single fraction by using the LCD. Once there's a single fraction on both sides of an equation, you get rid of the fractions by multiplication and solve whatever's left over. So we'll start with an easy problem. We have a fraction equals a fraction. Now remember, if you have a single fraction equals a single fraction, you can cross multiply and solve. That's one method. I'm going to use a different method that has something cool at the end. So we're treat this just like adding and subtracting. So step one is factor the bottoms. So this bottom 7, that's prime, can't do anything. This is x minus 1, linear, no GCF, can't do anything. So they're both prime. After you factor, you find the GCF. So we need a 7. There's 1 there, 0 there. So the most is once. Then we have x minus 1. There's 1 here, 0 there, so we need at least 1. And that's it. That's everything. Remember, this is our final denominator, so you might as well find the restrictions now. You skip the 7 because that's a number, but here's x. You set that equals 0. You add 1 on both sides. X can be positive 1. Once you do that, you're going to fix each fraction by multiplying what's missing, and you do the lazy way by just writing what's missing. The first fraction had one of these two things. It was missing x minus 1 over x minus 1. The second fraction has one thing, and you have 2. It's missing a 7, so times by 7 over 7. Once you're there, you're going to be lazy and call the bottom LCD, and you're going to multiply the top, fix it. So here I had a FOIL. So this is really 3x squared minus x minus 3x plus 1 over LCD. Same thing here, I'm going to multiply the top. 7 times 8 is 56, and the bottom is LCD. All right, now both bottoms are LCD. So when you have multiple fractions, to get rid of a fraction, you multiply the denominator. So I multiply both sides by LCD. Because they're both LCD, they both cancel out. So that's the nice thing by doing this method. I also combine my term for the top right here because negative x minus 3x is negative 4x. So all that's left over is the top. So you can set them equal. So 3x squared minus 4x plus 1 equals 56. This is quadratic, so you have to equal 0, subtract 56 to make it 3x squared minus 4x minus 55. From here you can solve by quadratic formula, or you can factor. I'm going to guess and check. So I'm going to guess 3x, I guess 11, 5. This is 15, this is 11. Can 15 and 11 make 4? Yes. But I need a negative 4, so the bigger number, which is 15, is negative. Once you're negative 15, to add 11 get negative 4, then you must check the multiplication sign for L. Positive times negative is negative, we're good. Once you have it factored, each factor equals 0. So to solve 3x plus 1 equals plus 11 equals 0, you subtract 11 both sides, then divide by 3. It's negative 11 over 3, and then to solve this one, you just add 5 both sides, you get positive 5. Before you box in this answer, you have to check, are any of these in the restrictions? If it is, you have to cross it out. But these are not in the restrictions, so both of those are the answer. All right, let's try a harder problem. Here's the problem here. So this fraction minus this fraction equals that fraction. So again, it's very similar to adding and subtracting. So first thing is you want to fix subtraction by making a plus sign and distributing negative 1. So that's the first thing I did right there. Then you're going to factor the bottoms. So this first one, there's a GCF of 2. I take out 2. What's left over is x squared minus 16. Again, I like multiplying the negative 1 and 5 right away, so that's negative 5. This bottom has a GCF of 3. What's left is x plus 4. Over here, this has a GCF of 2. What's left over is x minus 4. Now we're not done factoring. A lot of people forget x squared minus 16 is still factorable. You can square root those, so it's different squares. It'll be xx 4 plus minus. And everything else stays the same. Once you've factored the bottoms, you can find the LCD. So there's a 2. There's a 2 here, no 2's there, 1, 2 there. The most 2's that appeared is once, so I need 1, 2 in my LCD. I see 1x plus 4 here, 1 there, 0 there. The most times it appeared was once per fraction, so I need one of those. X minus 4 here, 0 there, once there. The most times it appeared was once per fraction. I keep going, 3, 3's new. There's 1, 3 there, 0, 3's there and there, so we need 1, 3. X plus 4 already took care of, 2 already took care of, x minus 4 already taken care of. Then we find our restrictions. This is our final denominator. 2 does not restrict, so that's the number. Here's x. Set that equals 0. Subtract 4, you get negative 4. So x can't be negative 4. This one, add 4 both sides, so x can't be positive 4. Once you have your LCD, fix each fraction. Multiply what's missing. This first fraction has 3 things. This is 4 things, though. So it's missing a 3, so I times 3 over 3. Can I use the shortcut by starting 3 with the division sign? The second fraction has 2 things. It needs 4 things. It's missing 2 of them. It's missing the 2 and the x minus 4. So I'm multiply 2x minus 4 over 2x minus 4. Now it's all 4 things, all 4 things. Even this last fraction do the same thing. has 2 things, it needs 4 things, it is missing a 3 and x is 4. But now all 3 fractions have the same denominator, so we're going to be lazy and call it LCD. I'll also multiply 3 times x, 3x, 3 times 2 is 6, I distributed. Even right here, when you multiply these 3 things, we're going to do 2 at a time, you eventually end up with negative 10x plus 40. So I did 2 times negative 5 is negative 10, negative 10 distributing to this is negative 10x, positive 40. The bottom is LCD. On the right side, same thing, you multiply these. I did negative 3 times 3 is negative 9. Negative 9 distributing to x is 4 gives you negative 9x minus 36, and the bottom is LCD. Once both fractions are the same bottom, you get rid of the denominators, the fractions, by multiplying both sides by the denominator. So LCD, LCD. Those cancel out. What's left over is your problem. This top equals that top. It is linear. If it's linear, get x one side, get x by itself. So I'm going to add 9x to both sides to get this. To get x by itself, I subtract 46 to get that. To get x by itself, I divide by 2 to get that. Before I box that in, I check, was this part of my restrictions? Negative 41 is not in there, so that is the answer. All right, one last problem. So multiple rate work problems are a very common example of rational equations in real life. The formula is j sub 1 over t sub 1 plus j sub 2 over t sub 2 equals j sub t over t sub t, where j is the number of jobs or tasks you complete, and t is the time taken per person. So say one person does paints 2 houses in 5 hours, because t is time. So it'd be 2 jobs over 5 hours. Sometimes this may be 1 house in 10 hours, so it'd be 1 on top and 10 on bottom. So sub 1 is the first person, sub 2 is the second person, and sub t is total together. All right, so if they're working together, it's a plus sign. If they're working against each other, sometimes it happens, it's a minus sign. And if it's more than 2 people, you just add another fraction, say like plus j sub 3 over t sub 3. Let's do a problem. So Miss Perry takes 20 minutes to wash her car by herself. Mr. Chesa takes 30 minutes to wash a car by himself. How long would it take them to wash a car if they work together? So the first misconception is you cannot just add the times together. It's not 20 plus 30 is 50 minutes. That's slower than by himself. So if they take longer together, there's no reason to work together. The other misconception is some kids think you can just subtract them. You can't do 30 minus 20. An easy one is this. If one person takes 30 minutes, another person takes 30 minutes, you can't subtract and say it takes them 0 minutes to wash a car. So you cannot add or subtract the times by themselves. You have to set up the correct fractions, rational equations. So the first person, Miss Perry, does 1 car, so the top's 1, and the time taken is 20 minutes. Now they're going to work together, so I put a plus sign. The second person, Mr. Chesa, washes 1 car in 30 minutes. So the top's 1, bottom's 30. Then equals, since we're going to define how many cars they're working on, they're trying to wash 1 car together. So the top is still 1, and the bottom, we don't know the total time together. We're going to find that. So usually you're trying to find this bottom thing right here. Now, if they ask you how long does it take them to wash 5 cars, you put 5 up here, and the bottom will be x time, we don't know. All right, so now it's just a rational equation we solve. So for step 1, factor the bottoms. This is 20, a single number. You break it down, tree branch. So 20 is 2 times 10, 10 is 2 times 5. So that's still 20, 2 times 2 times 5. 30 is a single term, so you break it down, tree branch. 30 is 3 times 10. Oh, I guess I did 2. 2 times 15. 15 is really 3 times 5. And then the last side, right side, that doesn't change because you can't factor it. After that, you're going to find the LCD. There's 2 2's here, 1 2 there, 0 2's there. The most 2's up here is 2, so I need 2 2's in my LCD. Then I see a 5, 1 5 there, 1 5 in the second fraction, 0 5's there, so you need 1 5 max. Then 2 we took care of, 3's new, 1 3 there, 0 3's there and there, so a single 3. 5 was taken care of, x is new, 1 x there, 0 x is there and there, so we need a single x. That's my LCD, that's all the final fractions. Then find the restrictions, that's our final denominator. So skip the 2, skip, because there's no letters. Here's the letter x, x can't be 0. So the bottom fraction can't be 0. Then you fix each fraction by multiplying what's missing. Each fraction, each denominator should have 5 things. The first has 3 things, it's missing 2 of them. The 2 is missing is 3 and x. The second fraction has 3 things, it's missing 2 of them. It's missing 2 and x. The third fraction has 1 thing, it needs 5 of them, so it's missing 4 things. So it's missing 2, 2, 5, and 3. Then we'd be lazy and call the bottom LCD and multiply the top. 3x times 1 is 3x. Then we're going to plus 2x times 1 is 2x over LCD. On the right side, 2 times 2 is 4. times 5 is 20, 20 times 3 is 60, 6 times 1 is 60. So 60 over LCD. Then we're going to get rid of the fractions by multiplying both sides by the denominator, which is both LCD. So those cancel out. And what's left at the top? We have 5x equals 60. That's our equation we're going to solve. So we have 5x equals 60. It's linear. Get x by itself. Divide both sides by 5. You get x equals 12. Before you box the answer, check, is that in our restriction? 12 is not in there, so we're good. So it takes them 12 minutes together to wash a single car. And that's it. I hope you enjoyed the video. If you have any questions, make sure you ask your teacher, email. All right, thanks for watching. Bye.